So now we are going to discuss the last topic of today's presentation, that is the new EM aided mesh tool featured in SimLab, which allows us to mesh quickly. So EM mesh is a specialized meshing tool designed to mesh 3D electromagnetic models using SimLab Flux solver. So it allows us to capture the curvatures and the tiny features precisely. So to the native Flux users, it is more similar to that of aided mesh in Flux. So before this EM mesh feature, we are to mesh the 3D models, we usually do the surface mesh with the mesh controls wherever it is required, and then the tet mesh. But now we can do with one-click meshing with the EM mesh feature in for 3D models. So to do this, so we need to give some information about the mesh size. Uh, it refers to the average edge length of the solid and the surface mesh elements. And then we need to give the minimum element size. So whatever the value we'll give here, the topological edges shorter than this value will be automatically removed. So we need to make as a minimum as possible. And then we can say the maximum angle per element. So this governs the surface mesh density on the curved faces by controlling the curvature approximations, and then the grading factor. So it controls the mesh transition on the surface mesh. So with this particular information, we can mesh the model. So it also creates the have automatic matching mesh between the surfaces, and you can see in the bottom example of the actuator here. So it is capturing the small features over here at this curved portions, having the deviation on the curved faces, and also we can see the grading over here on this on the surfaces when compared to the tet mesh. And we are not limiting here, you can also add extra mesh controls with along with the EM mesh. So this particular EM mesh feature is will be very useful whenever you go with the CAD based workflow. So here we can see the two examples, two different geometries, I can say. One is with the actuator and the motor applications. So here we can see the geometry with the planar faces. So here the mesh size has more predominant role to set the average mesh size here, because we don't see any curved faces, all are planar faces. And when another example model with the many curved faces, so we can see the small curved faces at the slot uh, edge portions. Here, the maximum angle per element has a more predominant role to set the curvature face mesh. So we can see here, whenever we, for example, the default will be the 15 degrees. So whenever we go with the 15 degrees here, will have a uh, you will have a 24 elements on the circular hole. So for better approximation, we can still reduce this particular maximum angle per element whenever you go with the more curved faces geometries like motor applications. So now we'll see a small demo in SimLab 2025. So now we can open an example of, so here it is a motor example. So we can define the solution, and then you can go to the mesh. So this EM mesh will be available in the mesh ribbon from 2025 version. So we can open it, and then you can choose all of your geometry, and it supports state elements. So here you can give the mesh size and the minimum element size as I explained you, and then you can click validate it. So the meshing will be very faster. So now we'll see the comparison between the EM mesh and the TET mesh. So here we can see the three models where we do have a different meshing over here. So the bottom one we can see it is only done with the TET mesh. So and here we can see it is not respecting the curvatures over here, and we can see it is, I think you can see it is not respecting the CAD as well. So the next example, the next meshing, that is the EM meshing. So now we can see here it is respecting the slot edges curvature faces here, and you can see the good meshing elements over here. So it is respecting the CAD. And I do have one more example to showcase you. So if you see the previous example here, if you can hide it, and now you can see the meshing is very has some deviation over here, right? So to avoid the deviation on the air gap faces, still you can have the control. The mesh controls you can define over here. We define the mesh controls on the air gap volumes. to have a finer mesh where we can expect some good results, especially for the cogging talk applications. Okay. And what is the advantage? Again, going for back to the uh, presentation over here. So with the help of the TET meshing, and you can see the comparison with the EM meshing over here. So first of all, the first advantage, the meshing will be very quick when compared to TET mesh, and you can see the mesh size as well. With the TET mesh, we can expect a minimum number of nodes, which will enhance our solving time reduction as well. And we can also estimate the good flux saturation at the curved faces edges of the geometry. So that's all from my end. Thank you.